Hey, hello guys. What's up? We're gonna make 3D point cloud projection today in HTML canvas. And yeah, if you guys are interested in some 3D stuff, welcome to the stream. Also, my health is not at best today, so you might see me sneezing and yeah, wiping my nose and all those kind of stuff. If you don't like those things, I don't know what you should do, but that's what it is. Okay, great. Let's get started. Okay, let's get started and let's see what we can do. So let's do like HTML point cloud. So let's go to HTML point cloud and let's close VS Code. Yeah, great. So the next the first thing what we'll be doing is we will be basically opening this in VS Code. Great. Yeah. So there's a couple of options we could have. We could use Vite for generating our project. We could simply generate our project, but let's use Vite. I think that's a better option. So we'll say yarn create Vite and we'll say vanilla. We'll give JavaScript as a dependency, and I think we can install the dependencies. Do you guys know about 3D projection? It's a really cool stuff. So there's something called 3D projection, right? So if you go to Wikipedia, you'll see this. What this basically is basically it helps you to project a 3D point on a 2D screen. What that means is basically you could, if you have a three-dimensional point, you could show it on a two-dimensional space. Yeah, there's few diagrams over here explaining how this works, but let's get our app up and running. So we'll say yarn dev, which should start our application. Great stuff. We have our application running over here. No, can you see this? I think my screen is getting chopped off. Yeah, now this is good. Okay, this is better. Yeah, so this is the initial stuff. Now what we're gonna do is we're gonna be simply deleting all the stuff which we don't need, and here's the main.tsx file. So what we're gonna start with is basically a canvas. We'll say const canvas is equal to document.create element. We're gonna call it canvas, right? And then let's put all the constants at the top, right? So we can say width, I don't care, but window dot inner width. Yeah, now after this what we're gonna do is we're gonna give this width to this and this height. So the canvas has the width and height of the screen. The next thing what we're gonna do is we're gonna say document.append body.append child, so which is gonna be adding that to our screen. Let's verify that. So if I go over here, this should be a canvas. Yeah, that means this is working as expected. Now what we're gonna do is we're gonna have the context ctx window.create context 2d. The next stuff what we're gonna do is we're gonna be having the animation loop, but we don't care about the animation loop right now. Let's get the first basics ready, then we're gonna try to get the animation loop and all those kind of stuff. By the way, just to show you that this is kind of like working, I'll draw a rect at like 100 of 100 width and 100 height, and I don't know why this is doing fill, but you got the idea, right? So now I can draw stuff on the canvas over here. Great stuff. So the next stuff what we're gonna do is we're gonna be drawing a rectangle or like a square. Like we'll be drawing a cube basically, right, in 3D space. So first of all, let's try to have like, you know, let's start with like very basic. Let's have three-dimensional cube, like three-dimensional point of cube. So we could space, we could do it like in unit method, so that when we multiply this with anything, it basically works. So let's start with the back. So it will be like x will be like -1, y will be like minus, yeah, that's what I want. Yes. So I think AI has generated all the, how many points are there in a cube? It's 8 points, right? So these are the 8 points of a cube, which is great. So this is x. So first of all, x, y and z. So this is over here, and this one is x in the positive direction, y, z, that means this side. Okay. Oh, it's building the back triangle first and then the front triangle, so that makes sense. Now what we're gonna do is we're gonna be converting these three-dimensional points to a two-dimensional representation of these points, right? How are we gonna do that? So there is like different kinds of projection. Like there's one thing called perspective projection, there's orthogonal projection, there's a lot of like different kinds of projection. But I'll tell you what do we need, right? What is the thing we'll need. So we have different kinds of projection. You can see 3D computer graphics, there are like various kinds of stuff. But what we need is like projection matrix. So 3D projection, we have it over here. Hold on, it's time for cleanup. Okay, so what do we need? I think do we need orthogonal projection though? So I think we need a projection matrix. This would this work? So this is a mathematical formula. I think this entire formula has the rotation matrix included in it. So basically there's two things. First is called the projection matrix. The next thing is called the rotation matrix, right? And right, so they have like, and this what you see over here, ax, ay, az, cx, cy, cz. I think ax and these are camera positions, maybe, not sure. Yeah. So a, x, y, z is the 3D position of point A that is to be projected. C, so, and this is the perspective of the camera, so that makes sense. So right now the camera position, we don't care about the camera position, so we just have to like multiply this. For us, camera will be at 0, 0, 0. So yeah, we might be able to move the camera, but this is the formula we'll try to use. Let's see how far we'll be able to go. So the first thing what we'll do is we'll have these matrix. How this works, that's beyond the scope of this video. That's beyond even the scope of mine. Like there's a lot of geometry and maths in this. You need to read this and all of like entirety of this, and then you'll get it. But basically this will give us what we want, right? So what we'll do is we'll just say project. We'll have a function called project, and then this will take two things. First it will take is an what do you say, first we'll need like 3D point, I don't know, that's a weird name. Like I don't know, point 3D, like which is the point you would like to project, or like let's call it point, right? Where what would you or like I don't know, coordinate, right? COR, and angle, right? So there's like two things, and this is like a simple version of that, but like let's do it. And then we could have like even a camera thing. So camera, right? And yeah, this is doing all these kind of stuff, but but let's try to use this exactly like this one. So what this is suggesting, will this work? Like, let's try this, right? I'm not sure. Let's try this. If this works, great. We'll see how this works, but if it doesn't work, we'll directly use this. By the way, I don't know what has the AI written, but what we'll do is we'll just yeah, we'll have a draw loop. So what do we have? I don't even see anything. Oh, it's because everything is at 1 1. For example, let's say if I'll start with like 100, like if I'll replace all the ones with 100, because ultimately we'll have to multiply. We'll not use this, but I'm just like seeing what happens if I try to do this. Yeah, I think this is working. This is working. So currently it is giving 000 as camera location. So we'll move the camera. So what we'll do is we'll just move the X and Y of the camera. I don't know, like maybe like we can move it like to -100x and -100y. No, y0 is kind of good, and z is +100 maybe. Yeah. So what if we do 200 or like +200? Oh, that's good. So that is giving us the projection. So just to see, like just to visualize this, what we'll do is we'll just take we'll probably take like mouse position. So mouse x is equal to 0. Mouse first of all, this shouldn't be a const, that's also a thing. This should be let, right? And then I mean, yeah, so we'll just update the mouse position based on all those things. And then what we can do is we can just, instead of giving the camera position like that, we can give the, I don't know, mouse x and mouse y maybe. Let's see. That is like the camera position. Okay, that's kind of weird. That will be kind of weird, but there is no rotation angle. Oh, so the angle is not like, oh, that makes sense. Okay, let me 0, like, you know, y x y z, right? So z will be like let it be like 200 or something like that. And then what we can do is we like it is at 45-degree angle, right? So I think that's the, what was the, can you tell me what you're doing? I am projecting 3D points on a 2D plane, like bunch of 3D points on a 2D plane, and then I'm having a camera through which I can track it. Most of the video games work like that. So I have the COR, which is coordinate, and then the angle is 45. I just don't like that. Let's make it like mouse x. That's weird. Okay, what if we just give like, I don't know, 120? That's just not appear. I think we just messed something up. It's visible, but let's call it mouse x. Yeah, you can see the cube is rotating. You can see the problem is this x, the y direction should be like 300, and like the x should also be like 300 or something like that. So you can see the there is like a 3D cube rotating in like 2D space that is happening. So first of all, this is the main part. I think this is just the the solution of this entire equation. So like you solve this. I think you can 3J, bro. 3J, I don't want to use 3Js. I just want to understand how does it work from the first principle. There are 1,000 different libraries I can use, but like I just want to make it from scratch, right? That's the goal, to learn 3D from scratch. But this is cool, right? So we can rotate this. But why to settle on like only these points when I could have like complex 3D planes. So let's try to make something interesting like this. So okay, now I'm thinking like, can I so this is cool, but can I like make this like mouse X and mouse Y? Oh, that's kind of cool. See, this is like I can change the XY direction of this. But the problem is the kind of projection which I am doing is not like, it's not the kind of projection which I want. Like for example, let's say I'll give you an example, right? This is not the projection which I want. So just for an example, what I'll do is I'll just make this like probably like 45 degrees or like whatever, like 0 degrees, right? So I'll have 4 points. But if like for example, imagine looking at a building from like a very far distance, right? You move from left to right, so you see one side of the building, and then you move to the right, you see other side of the building, right? So this is not the correct kind of projection which I want. This is just like the most simple version of the projection. What I want is a perspective projection. Like this is what I want. This is a very simple projection which I don't want. So I want perspective projection. We'll change this, right? So to make it work, to make perspective projection work, what we need to do is, first of all, we'll have to create a small math library, or like I think we already have like some math library. So we have math.js. We can use math.js, I guess. Yeah, this is kind of good. So we can do like matrix multiplication and all those kind of stuff. So I want to ask you guys, should I code my own matrix multiplication stuff, or should I use the math.js stuff? Let's code my own math stuff. I think that's gonna be cool. Should I don't know. Nah, let's use the math.js. So what we're gonna do is we're gonna go to get started. We're gonna be like just copying this. We're gonna say yarn add math.js. So that's gonna. So first of all, what we have to do is we have to take the matrix, convert it to, I think that conversion is not required. So if I just go and search for matrix, right? Okay, cool. So 2 0 minus 1 3 is 2 arrays, right? Which is multiplied. Makes sense. So okay, so let's try to do this. First of all, we'll have to extract all of this like x, y, and z coordinate systems. So I'm pretty sure AI will do this for us. I mean, but I see right now the AI will give me the answer. See, so how is this different? Like just curious. This is wrong, in fact. Okay, so it doesn't even matter. So let's kind of like try to copy the formula from here. So we'll import math.js from the top. So we'll have like so we have math.js. So the first thing is x projection is basically exactly this. So cos of angle, and wait, why is this 0? Oh, so this is like fourth, but I don't need the fourth one, so that's kind of enough for me. and then y projection. Yeah, that's more of what I want. So cos 0 sine negative sign. So why is this like positive sign? Oh, because my coordinate system is opposite, so it goes from the top to bottom. That's why this is opposite, right? If that makes sense. And then z projection. So yeah, and then this is the camera projection, but I don't know why is this like this. Nah. Final. But why it is giving me the, oh, it's giving me the 3D point after the perspective, and then I can project it. Okay, got it. So so let's call it perspective. Okay. And then ERSP perspective, right? So now I don't want this. So basically I want like match.js dot, I don't know. Can I directly import matrix? Like, is that a thing? Matrix. I could have like, yeah, that would have been better. Not sure. Why is this camera? I don't want the camera projection like that. So let's multiply all these matrices. So for that, what I'll do is I'll just pass this over here so that becomes a matrix now. Can I simply multiply it like yeah, it's basically subtracting it, but why it is like, okay, maybe, okay. Yeah, makes sense. Then it multiplied the so it's basically doing the point multiplication, so it's multiplying this with x and then the result with y and so on. I also are getting it what this is. So we have a camera projection now. So now project to 2D, that's what we want to do. So maybe distance, is the distance even required? Maybe required, not sure. So yeah, so we have all this. So we have project perspective, and let's call this function instead of what we were calling before, and let's see what do we get. Are we getting any errors? Yeah, match.js is not defined. It's saying match.js is not defined. What the hell? What do you mean match.js is not defined? How can the match.js be not defined? Do we have a CDN for match.js? I don't know. A match.js CDN is just not working for me for some reason. I think this is not how you do it, or there's something else. What's the reason? Why is it not working? So if I just go over here, you see like matches not defined, but I do have matches in my dependencies. Let's have it as a CDN, like who cares? Yeah, this is match.js as a CDN. So we're gonna copy this one, copy the script tag and like paste it before this so that sorry guys. So we have the match.js over here. I think now we can do like math dot and all those things. So uh const this is equal to math. So we'll just take out the matrix from maths. Probably that would work. It's saying math.js not defined. Where is the math.js? Oh, math.js.cos. No. So it's not math.js. That's kind of incorrect. It should be math.cos. Oh, that's the reason. Is this? Oh, okay. So it was working. The problem was okay. That makes sense. So now we can get rid of this one. Okay, it was working, but so we just need cos and sine. So we can just remove this math.js dot from all the places, and that should kind of like that should work. Multiply is not defined. What do you mean by multiply? How do you multiply the matrix? Oh, add multiply. There is add. I mean, what do you mean? Oh, it's multiply. What do you mean by multiply? This is like, oh, that's stupid. So, oh, it's a function over here. Okay, now it should work. So we have a matrix column unmatch. So we are trying to multiply two matrices which are incompatible. We'll see where are we doing this mistake. Yeah. I just want to see like if we do 0 0, are you able to go over here like till this point successfully? So if I just log my camera projection, camera projector, it's this. No, we are not even able to go to that point correctly. What's the mistake? So it's saying I'm doing a mistake in main.js 85. Where is 85? Oh, so this function 62 is 60, okay, over here. So the problem is here what we get like so let's see what would be this result. So let's multiply these things. I mean first. So what we'll do is we'll just say I don't know, this works. X projected. We get a dense matrix of like something like this. Why do we have like four like why do we have four values, four output? I don't get it. It shouldn't be four, it should be only three. Like for example, why I'm saying like this should be three is because it's I think row times column. So the first row is three and the column over there is uh 1, so it's like 3 times 1. Why is there fourth element? I don't know. Let's try to find it out. Okay. Oh, so it's like this. Okay, makes sense. Just to like see how does the matrix work for this. Let's multiply like I don't know. Let's say matrix 1 is a like matrix of like 1 comma 2 and then 1 comma 2, and let's like have another matrix something like this. Yeah, what does this gives us the result? So this is correct, this is valid, but we have some weird results. Why? I don't know. I think input is wrong. The only thing which makes sense is the point is having okay, makes sense. So what is the point for us? That's minus 100, minus 100, minus 100. So at 61, we have the first one is array of 3. Wait, why do we have 4 numbers? Why do we have 4 numbers in these? Oh, this is stupid. This is the reason why it wasn't working. So we have 4 things. Like that shouldn't be the case. So if you see the Wikipedia, it's so there's no 4. This would work now. This should work now. So we have everything has 3 now, right? So yeah. So this shouldn't give error now. Let's hope so. So if we just refresh, this is not giving us error, but let's see what is the result. Why is it 4? Oh, so this one, stupidity never ends. There is also 4, so the last one I have to just cut it off. Yeah. Also, like, why do we have? I think this will be some kind of issue. This wouldn't be existing. So let's say let's see what do we get as a camera projection. Camera projected. This should be. Why is it 4? Oh, so I must have missed somewhere. Oh, because of this camera matrix. This shouldn't be there even. Like I don't feel we do even need this. So we have Z projection matrix. Now what we have to do is we have to subtract the we have to subtract this the point matrix with this the camera matrix and then and multiply it with this. So basically it will be like subtraction will be subtract z z subtract Z projection with the camera matrix, but no, it should be Z projection. It should be basically so it should be the point, because is the point, yeah, and C is the camera. So I think where is the camera? It shouldn't be directly like that. So it should be cam matrix of camera, and then I can say cam. Yo bro, are you Indian? Yes, I am. What's up? So we have camera and we have this whatever like sub thing. So which we subtracted. Now what we have to do is we have to like I don't know, like this like final final matrix should be this multiplication of this. And now let's see what we have. Let's like just log this and see what we get. So we get like a 3-dimensional matrix, which is right. Like this is what I would expect this. But now we have to like project this in some this is just stupidity. We are able to draw something, but it's not right. So project to 2D. I don't know, it's taking some distance, it's just doing that, it's having this. Will this work? Yeah, it looks, it's working. Oh, that's great. So let's decrease the distance, but let's make maybe like 50. Yeah, it's doing the perspective projection thing, but there's something off, so we're gonna fix that. So what we'll do is we'll just we'll have like a function called scale that is gonna scale our matrix. We'll say scale man, I wish I could code without ChatGPT every time. It's okay using ChatGPT unless you understand the concepts. There's nothing wrong if you have a tool, don't rely on it for your intelligence. Rely on it to do redundant tasks. For example, like over here, like I know how this projection works, right? And then copying these individual matrix one by one is like a redundant task, right? So if like ChatGPT is doing that for me, that's intelligent, right? That will save your time rather than just save your time with ChatGPT. And it's a waste of time even if you use it for some intelligent stuff. You know, I have tried solving at this current stage, right? I've tried solving some programming stuff, and then I realized I could have solved it on my own way quicker, way easily. And yeah, it's not good for like extremely complex tasks. That's what I have realized, by the way. Okay, so we have this formula running, and we have the perspective projection working. We just have like our point cloud is very small, so we just want to scale it up. So for that, what we'll do is we'll just yeah, it's working. So for that, what we'll do, we'll probably multiply this. So over here, right, just for fun. So we have core, and then what we can do is we can just say point is equal to multiply point with z projection, not point with like matrix. Let's multiply this with like I don't know, 40 times across all. This just broke this. Okay, we'll try to do something else. So what we'll do is we'll just take this, we'll just remove this, and let's make it like 300, or like even more. Let's make it like 900. Yeah, so now you can see this kind of like works like projection, but our projection depth is very less. So over here, like we have it like this. Let's make it like 500. I think this is an issue. So what if we like it's 0? What, how does it work? No, 100. I wish I could zoom. So what we'll do is we'll just take one more parameter called zoom, and so this will help us to zoom. So currently we are not passing any zoom factor, so we'll have to pass, like, let's zoom it twice. Let's see what happens. This doesn't help us in any way. What if we do it like, it should be itself. Why does it break? It shouldn't break. Like I mean, I don't get it, but yeah, whatever. Now we're gonna do something amazing. Now what we'll do is we'll just take some Blender. Hold on, there's some wind coming from this window. Close this one. Now what we'll do is we'll just take some very complex, not complex, but we'll take a large point cloud from some Blender model, and we're gonna project this over here. So let's see how does that go. So Blender models, and free, I don't know, Yeah, I think we'll get some free Blender models. We want something simple because something very big will crash our browser, which I don't want. So let's find something very simple over here. Uh, this dragon, I don't want dragons. 3D. Why everything is so detailed? I want something very simple. Uh, no, this is very detailed. Yeah, these looks good. So what we'll do is we'll just let's take this chair for example. This chair looks good. So now we want to download this as an OBJ, right? So we'll just go to free download, and probably this will give us an option to download in a supported format. We want an OBJ file from this basically. Why are you making me wait? Just give me my model. Just wait. Uh, okay. So we want the OBJ file, so we'll just download this one. The OBJ one. Oh, come on, bro! You want me to sign up? No. I will not sign up. Yeah. So this is kind of good. Let's go something like, I don't know. Furniture is kind of good. We don't have an OBJ file. Like this is good. I'll have to download this and like probably open this in Blender, which I don't want. This is good. So we have this OBJ file. We can download this. Oh wow. So we did download this. So now I would like to show you like what this is actually all about. Like what does an OBJ file contains. But before doing that, let's move it to our project, I guess. So an OBJ file basically contains a bunch of like 3D points, right? We just have to parse this and draw this. I'm sorry, I must be sounding like extremely weird, I guess. So we have these points, and we're gonna. So these are faces. Faces we don't care about. We just care about the points. So what we'll do is we'll just have the give the user the ability to select a file. So we'll just have like a input type will be file, and let's give it some ID, maybe obj file, right? And I'll go to the main and probably have the input file. uh yeah, that's the name. Now what we can do is we can say input file dot on change. We'll have some event, right? And then we'll have a file. I think, yeah, this is what I want to do, surprisingly. We don't want to console log this points basically. Then this cube point should be that points. So for like just for now, like just for now. So let's do one thing. Let's make it like a let thing, and let's say the cube points is equal to points. Let's see what happens. Uh, let's refresh this. Oh, we'll have to select a file, I guess. Uh, this is the project itself. Let me find this. Where is my project? So, yeah. And this is HTML point cloud, and this is the OBJ file. There you go. It's very small for some reason. Like it's there in the middle, it's there, but we cannot see it. So for that, what I need to do is I need to create a zoom function. Scale points, right? So this is scale points, and then what we're gonna do is we're gonna be saying so we'll have to select this again. Still, why can't I zoom it? And it's very small in the middle. Reason you can see that dot, right? Uh that's really annoying. Let's do one thing. I have an idea. So can we go over here, right? And like whenever we parse this, we multiply this with like, I don't know, 3000. Yeah. Uh is that too much? Maybe. We'll know. It's still this is pretty annoying. Let's see what do we get as a cube points. Like what are we even seeing over there? Is it 31? Okay. So we'll have to log this like every time, because not this one, but okay. Can you just tell me what are these? This is fine. This is fine. I don't know why is this. Wait, have we? Oh, wait. Wait. No. Why do we not? Why are we not using the Z? Oh, we are using Z projected. No, we are using G projection. What is G? Oh, no. This is stupid. We don't. So, oh, our formula was wrong. We were not projecting in Z direction, I think. Oh, that's the point. Oh, let's fix this. I think that is the problem we have. So we go over here. We see. Let's match this again. So this is our X projection, Y projection, and Z projection. X, Y, Z. We multiply this with the. So I think this is the mistake. So what we'll do is we'll just multiply this. Does it? I don't know. Let's call it A1, and then multiply this one, and A2 will this one, and Z projection will be this one. Yeah. So we are taking some zoom, and then we are multiplying. Right now, let's leave zoom. We don't care about zoom right now. So just we are multiplying this with this, and then this with this. So this with this, and then A1 with the Z projection, which we finally get. And then we have to multiply this with the subtraction of these two projections. So we get A2, and then A2 has to be multiplied with the subtraction. So this should be A2, and then probably what is this? This is like the normal projection matrix. Yeah, let's see. This bunch of points, but I cannot. Oh, that's so irritating. Let's move the camera to 0 0, and then why it is 600? I don't know. It should be 10 or something. Ah, okay, the camera position, that was the issue. But it is there, but it doesn't make sense. I think I'm just like rotated in a wrong space, or like I'm multiplying it this in a, that's the mistake. So Z probably, let's move it like 100 points away. Why do I have to select this every time? I don't know. 100 is too far away, so then like 40 should be fine. So let's rotate this like 45 degrees or something like that. Uh, what the hell is this? We are doing something stupid in the matrix multiplication. I'm pretty sure about this. So let's match it once. So alternately, without using the matrix, let's replace ax minus cx with, oh, so we can do this also. Like this is cool. So we don't, let's rewrite this function, bro. Like this is super stupid. So we can say, yeah, of course, there's this error. Why do we have four angles? I don't even get it. Uh, what is SZY? This is not happening like this. Let's read a little bit more about perspective projection. I think then we'll understand how this works. Uh, uh, this looks good. Let's see. So One second. uh I think there's something wrong with my stream. I think there's something wrong with my stream. Okay, whatever. Let's continue. So, like in like normal 2D, normal 3D projection, which I have done before. If you see, if you write 3D projection, like perspective project. So this one. So this one was cool. Like this is like a
some offset
normal,
and make it
like normal. Like this is a normal, like like normal projection which I did, like I showed right now before. But like, I was just thinking, what if like, hold on. This is orthographic projection. Orthographic is easy. Like orthographic is like what we did before. But we want the projection one. What is ax minus c? Oh, so it's oh, got it. So basically cy is cos of y. So basically we can do this. So let's call it dx is basically cos of the angle multiplied by, no, we don't want to do this. So we want to multiply the cos of rotation. Rotation should be a matrix, right? Because rotation in the x, y, and z direction could be different. So what we'll do is we'll have so rotation will be so angle will be a matrix basically. That's what I'm saying. So let's convert this to a matrix. So angle mat is matrix. Yeah, this is the rotation matrix, but I just again don't care about that. So just I want like the angle, right? That will be like a matrix. Now what we'll do is we just have like the cos, and now we have to multiply this with the s of z. What is s of z? Sine of z. Uh, Sine of the, first of all, angle is an array, right? So x, y, z. So I can simply say, if this is saying of y, I can say angle at 1, and then sine of uh, z, then I can say angle at 2, right? So that should work. Come on. Oh my keyboard is like dying for some reason. Yeah, so I can just say angle at 2 will be angle at z for sine, and multiplied by coordinate at 1. Exactly, cos at, wait, hold on, no, uh so this sine multiplied by coordinate at y, uh cos at 2, no, cos at 2, that's correct. Then we want to multiply this with x, and what is x? That's 0, right? So then we want to, so all of this, finally we have dx, dy, and dz. This is like more without using matrix way to do this. Now what we're gonna do is we're gonna have the dx, dy, dz after the rotation and the projection matrix. We have to like project this on 2D space. So f is like the distance. Yeah, whatever. Would this work though? Not sure. Oh, so x is not, x is, this is stupid. Okay, so basically in our case, x is equal to, yes, this, y is equal to this, z is equal to this, then dx will be this, dy will be this, and dz will be this. So yeah, that's more, that's more of what we want. Then we cannot name this xyz because this will be conflicting names, so I guess we'll have to choose some other name. Yeah, but will this work? That's what we want to know. It's a unexpected argument in angle cos, where, oh, because, oh, makes sense, because here when we are calling this is 45, which shouldn't be the case. So in the x, let's say 45 and 0 is what we have. Whoa, 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 whoa. We have something. We have something. We have something. Oh, great. Great. We have something. I'm pretty sure like I have figured out the geometry of this. Now I just have to like figure out the zoom and rotation. And then I'll be able to see the bunny, I guess. So after this, what I'm gonna do is let's try to play something with this. So we have the scale. I think we don't care about the scale right now. I don't know why are we even passing the scale right now. So uh can't we cache this? Like let's cache the file so that, or like I don't know. Selecting this again and again is annoying. Yeah. So XYZ could be a little bit more, like maybe 20, and or like, and rotation is 45 45 uh 45. XYZ all directions 45. What are we even doing? What are we even seeing? I don't know. First of all, this light color is completely killing my eyes, so let's do something about that. So here where we are getting the context of the canvas, where over here, let's do alpha false. So this should go black, and then over here, and then I can say fill color or something like that. Yeah, I can just do ctx.fill style, not black but white is what I want. So if I go and select the file, I should get this. This looks cool though. So now what we're gonna do is we're gonna be this rotation matrix, we're gonna be handing this over to mouse X and mouse Y. Let's see what happens. Let's select the file. Whoa, 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 whoa. Hold on, hold on, hold on, hold on, hold on. This is just glitching like hell. No, I don't want this. So if I just do like mouse, like this will be the same, but the camera position will be like mouse X, mouse Y. Again and again I have to select the files. That's kind of annoying. Okay, that is looking like a bunny. See, that is a bunny. Our perspective is wrong, but you wouldn't tell that is not a bunny. I don't know. You guys, can you guys see the ears and all? We have a camera. We need to figure out the rotation. Let's do the rotation with the scroll wheel. I guess we need like some way to do it. Uh, uh so let's do like x rot, like x rotation. Like let's make it 0. Y rotation 0 and Z rotation 0, and then window dot on key press, on key down, and let's assign these to various keys. So if e dot w, then do this, then and then wsa. I want xyz. So if it is x, if this is y, and if this is z, then basically do like +1, +1, and +1. And what we're gonna do next is we're gonna use, oh, so z, we just are not using z. Great. So we have x, and this is not y, this is y, and we have z. So this should be z rot, right? So these rotation. So we have all these things. Now we have to plug this in over here. So what we have to do is this will be x rot, this will be z rot, and this will be no, will be y rod, and this will be z rod. So we have xyz rod, and now what we're gonna do is uh, we're gonna be selecting that file, opening that file, and no x. Is it even working? Oh, so there's like some error. Oh, we are trying to assign this to a constant. That's stupid of me. So this shouldn't be a const. This should be a let. Uh, yes. Should we have the caching? I think we should have the caching. Okay, I think we are too much zoomed in or something. Like we have to zoom out, I guess. Somehow we'll have to zoom out. This is too much zoomed in. So let's go like 200. That would again selecting the file. Okay. Okay, I think again I'm too close, so let's even more decrease the like perspective. Maybe like 400 will be cool. Now tell me you can't see the bunny. Tell me you can't see the bunny. There is a bunny there. There is definitely a bunny, right? But we just we just like we are messing up with the views so badly, and also like okay, this is like something wrong with this. So what is f200? So I think this is my focal point, right, of my camera. And adjusting this, like like if I just make it 500, what will happen? I'm just curious. Also, let's start caching. I think enough of selecting the file again and again. So we'll say do. So once you do this, just say local storage dot set item few points, and then like this, and then yeah, that's better. So now if we select one time, it will always be there. I don't know why we can't see this. There is a bunny. Why is this like this whatever, like this what do you call, there's like this offset, like, right? So I don't know why is this offset there. Could we do the better? Could we do it better though? Like I'm just thinking. Now the benefit is I can just, it will be there. See, I don't have to select the file again and again. Let's fix this. Let's fix this. Like hmm. One more thing. Let's go over here. Say style body padding 0, margin 0. Okay, now we have this. So this is mouse X, mouse Y. How do I control the cursor though? So if I just like subtract like something like 400. This will fix the perspective like on some level. Yes, this has fixed the perspective on some level, but this is very random again. Okay. This very dense cloud, that's the problem. That's also a problem. And let's rotate this also. Like what if we just, oh, we have the rotation, right? So we can say X rotation. Does it even work? Is it even working? I don't know. Let's go to, let's rotate it like by 10 degrees. And what do you mean by everything should be plus? There's no minus. Yeah, it is working, I guess. Wait, what the hell? If I'm pressing Y, this is just going insane. Z? Yeah. With Z also this is going insane. But now you can see I can zoom in, zoom out. And let's rotate the bunny. I don't want to see the back side of the bunny. I mean. So let's keep the initial angle like X angle by, like, let's rotate it as by X by 90 degrees. Let's see what happens. So if we just refresh, yeah, this is good. At least we can see the front of the bunny. Also, I want to have like the access to zoom, I guess. So it will be 0 initially, and then window dot, this will be controlled by scroll wheel. On scroll, yeah, so zoom will be the I guess. And why is it 3000? First of all, this should be like 1000. That's enough. And this should be the zoom. Whoa. Tell me this doesn't look sick. Oh, I can, whenever I scroll, I can just control this. This goes far away from me. Great. So let's control the plus and minus, that if yeah, that's more of what I want. This doesn't work. What is delta though? Why is it 0 though? So starting should be like 100. Why doesn't it work? If e dot, I don't know. How to do this? E dot scroll. So so we can do like this delta y, but does it even give a value? I don't know. Zoom plus equal to e dot delta y. Let's see what does the event e has in itself. So we have this scroll event which doesn't have anything called delta, which is weird. Oh, it's wheel. Okay, that's interesting. I think then it would work. Yeah, now this works. This is what I want. So I can go inside the point cloud and I can explore the bunny. I can come out and I can see the bunny. And this is great. Absolutely great. Now what I want is I want the ability to change the XY based on the like what do I say? Based on like the up, down, like I want to change that. So X cam X is at 0 0 0. So if up, yeah, that's what mode I want. So so this is the camera position, right? So rather than give it like this, let's give it like cam X, cam Y. So we are going like this, and then oh, so we have done the same mistake again. This should be let, and so let's go sideways. Let's go up inside, and great. Now we can explore the bunny, but we cannot rotate. That's kind of weird. So we can go in the side of the bunny. This works. Up works. Side works, but left and this doesn't work. So let's do one more thing. So yes, so that rotation definitely has some issue. So we want to rotate it like in the X directions. Pressing X, would that work? I think dragging should rotate it. So like I can zoom this in now. I can have like X and Y control now. But I cannot rotate it. That's kind of weird. Let's see. So these are the rotation controls. I think cam Z. Cam Z is the zoom, right? So left, and there should be up, down, left, and there should be a right key as well. Yeah. Cam Z is the zoom, so yeah, it's the same thing. Then I don't need that. How to rotate this? I cannot rotate this for some reason. Y rot plus equal to 10 on X. I think rotation has like the stupidest control. Uh, let's let's uh let's have like a drag based rotation control. Right. So or mouse position based rotation control is also kind of cool. So we already have the mouse. So what we can do is we can just say mouse X and mouse Y. So this will be a little bit weird, but let's go a little bit far away first. I don't know where is this like rotate. What's the origin of rotation? Like I can definitely rotate this, but something very weird is happening. Uh, let be what it was. I just want to change 0 degree in the X direction. 0 in the Y direction, also 0. In the Z direction, I want 90. Maybe this will make our work a little bit easier. What the hell? What did I do? I think we'll have to do like 45 over here. Maybe this will. That's it. Great stuff. So, oh wait, is it left right is shouldn't control uh I don't know, bro. This was fun. So we might try something more complex some other day, but thank you for watching and bye bye. Have a great day. We'll build something more complex, probably something amazing. But for now, this is what it is. Thank you for watching this video and bye bye. You just had fun. We'll build something interesting.